Hello everyone and welcome back to the Nail It program. Now today I'm going to be teaching you how to do ionic equations, but before anything, first I'm going to show you the things that you need to learn before you know how to do these. So these things that I'm going to show you right now are things that you really need to know before you even start watching the video on how to do ionic equations. So these are things you need to learn. Of course, these are the symbols: aqueous, solid, gas, and liquid. They're state symbols, which show the state, the physical state of a substance. Here are the basic formulas for things, for very essential compounds, to be honest. So you've got oxygen, O2, hydrogen, H2, water, H2O, ammonia, NH3, chlorine, Cl2, carbon dioxide, CO2. Here we have, okay, by the way, this is the AQA sheet. I have taken this from AQA. This isn't mine, I haven't made this. But these are the basic formulas of ionic compounds, or should I say the ionic charges, that you do need to know. You have to know all of these. So you've got hydrogen, 1 plus sodium, 1 plus silver, 1 plus potassium, 1 plus lithium, 1 plus ammonium, 1 plus barium, 2 plus calcium, 2 plus copper, 2 plus magnesium, 2 plus zinc, 2 plus lead, 2 plus iron 2, 2 plus iron 3, 3 plus aluminium, 3 plus chlorine, 1 minus bromine, 1 minus fluorine, 1 minus iodine, 1 minus hydroxide, 1 minus nitrate, 1 minus oxide, 2 minus sulfide, 2 minus sulfate, 2 minus carbonate, 2 minus. So you need to know all of these formulas if you want to do ionic compounds. Right, so now I'm going to move on to the actual video. The ionic equation, the method for it. One golden rule we first need to know is that the ions in an ionic compound cancel all the charges. An ionic compound forms as the ions, what do? Okay, this will be explained better in the ions video, but all you need to know at this stage is that they equal up with the charges so that the overall charge of the ionic compound is 0. So the opposite charges balance with the same charges but opposite signs, and this causes an overall charge of 0, which causes the ionic compound to be neutral. So here's some examples of what I have just said. For example, you have Mg2+, so that's the ion on the charge of the ion, Mg, magnesium, is 2+. You also have oxygen, so the charge of the ion in oxygen is 2-. So when you want to make an ionic compound magnesium oxide, you need to make sure that the 2+ and the charge of the magnesium and the charge of the oxygen balance. And in this case, they do without adding any numbers. Because there's already a 2+ charge naturally, there's already a 2- charge naturally. Therefore, that's basically how you write it. You just write it as MgO because they are balanced. The next example, we have H plus and SO4 2-. Now, as you can see, when we form this compound, the 2- charge and the plus charge aren't equally opposite. Here we have a 1+, but here we have a 2-. Therefore, how do we balance it? We make 2 hydrogens. If you have 2 hydrogens, you end up with a 2+ charge because each hydrogen atom is 1+. 2 hydrogen atoms gives us 2+. SO4, we don't need to do anything to it because it naturally is 2-, which gives us H2SO4. So the only thing we've put into this formula, normally you would probably, if you were to write it like this, which is obviously wrong, you would write it HSO4. But we've just done H2SO4 to balance out all the ionic charges. So that's how to balance out charges. Now, the next thing that we do need to look at, the next golden rule, is spectator ions. So we need to know about spectator ions if we actually want to know how to make ionic equations from chemical equations. So what are spectator ions? Spectator ions, they do not participate in a reaction. So they remain the same in your reaction. They do not react, they don't change state, they don't change in terms of their rearrangement or their the amount of atoms in it. Here is our equation that we're going to turn into an ionic equation. CaCl2 plus 2NaOH gives CaOH2 plus 2NaCl. The green parts are the state symbols as I have shown here. So we've got this aqueous, we've got this as aqueous, we've got this as a solid, and we've got this as aqueous as well. So our first step is to write the aqueous ions separately. Where are aqueous ions? We've got one here, here, and there. So we just need to write that separately. Instead of CaCl2, we're going to write Ca2 plus 2Cl minus. So we've just basically broken it apart. We've split it apart into all the ions it consists of. We've done that for every single compound, as shown. And our next step is to cross out any spectator ions. Now I've circled it because I don't have that much space. But what we do is that we see this and we see which ones haven't changed. So for example, let's look at Ca2+. Has Ca2+ changed in the products? Yes, it has. It's no longer an aqueous ion. It's now a solid. It's a solid. It's not aqueous any longer. That means that the charge is 0 because it's a solid. It's not an ion. Now, so that means Ca2+ has changed. That's not our spectator ion. 2Cl minus. Let's look at this here. It's still 2Cl minus. That means it's a spectator ion because it remains same in the reaction. Same applies to 2Na+. But 2OH minus, just like Ca2+, is a solid now, which is why that has changed and that's not a spectator ion. So our spectator ions are going to be 2Cl minus, 2Na+, 2Na+, and 2Cl minus. Well, basically, our spectator ions are Na+ and Cl minus because they remained exactly how they are in the reactants and the products. Now we just need to rewrite the equation. If I were to just cross these spectator ions, just cross them out, okay, like that. And we just need to rewrite what we're left with. We've got Ca2+, we've got 2AH minus, and we've just got this solid here. So we rewrite that, and that is our final ionic equation. Remember to keep the state symbols though. You always need to keep the state symbol. So this is aqueous, this is aqueous, this is solid. That's what you need to keep, and that's your finished ionic equation.